Thanks, Rachel. So just welcome everybody to this webinar. Just want to make some quick introductions and then we'll dive right into the topic. So I'm Tom Siga, co-founder, CEO of BlastWave. And just as some background, I spent my first decade of my career in factories, my second decade of my career at Apple, and then my third decade of my career, please don't do the math, was starting 4 startups. So with that, Chuck, why don't you introduce yourself, please?
Hey everyone, my name is Chuck Weisenborn. I am the Public Sector Chief Technology Officer at Dragos. I've been at Dragos since about October 2020. I also have another hat on the National Guard side of the house, where I'm blessed to serve our country supporting topics related to critical infrastructure. Thanks so much for having me, Tom and Rachel. Excited to talk about Zero Trust in the space with y'all.
Great. And Chuck, why don't you just go ahead and tell us just a 30-second snippet about what Dragos does, in case anyone doesn't know.
Yeah, Dragos is an industrial cybersecurity company focused on a mission to safeguard civilization. What does that actually mean? That means that we want to find our adversaries before they can cause an impact and prevent us from, and our children from, not having power or water or the basic necessities of life. One of the unique things about Dragos, we're also a threat intelligence company. We have a team of amazing folks who are collecting against adversaries on a daily basis, which powers kind of our ecosystem, which includes both threat detection, asset management, as well as incident response and kind of general consultative services.
Yeah. Fantastic. And so BlastWave, we protect critical infrastructure also. And in fact, what you're going to see at the end of this video is we are basically 2 sides of a handshake. And by working together, we can provide a very solid solution for industrial control system protection. So with that, let's start the slides, Chuck, if you would, please.
Yep, I'll get that shared here in just a second.
Perfect.
Awesome.
All right. I think we're gonna talk about the agenda. The first thing that we're gonna discuss, obviously, is intros, and why Zero Trust. What is it about Zero Trust that has everybody so excited, and what's so important about us working together to try to achieve this? The second thing I want to talk
about some of the oh, sorry, Tom, go ahead.
No, you go ahead.
Yeah, we'll also talk about some of the Department of Defense Zero Trust requirements, and kind of their unique applicability to operational technology, networks, assets, and processes.
Yeah, and then we're going to talk about how to operationalize this and what can we actually do once we have this baseline of knowledge. What are the tactical things that we can do to try to deliver Zero Trust in these OT DoD environments?
So when we talk about Zero Trust, a lot of folks tend to come at it from this is a requirement, somebody is telling me that I have to do this thing. But if you dial it back even further, I always try to encourage folks to think about the problem that we're trying to solve with Zero Trust. And there's really 2 sides to this equation. One is the threat side of the house. We have adversaries that are building capabilities tailored and focused on operational technology, protocols, and assets. We have adversaries like Volt Typhoon that are, and their kind of ICS-focused component, VoltSite, that are using very advanced, very mature techniques to operate within environments without bringing anything external. So they're living off the land using, environment native resources that are already trusted in most OT environments. And we know that these adversary groups, have placement, they have access, they have capabilities, and multiple times over the past years, even predating Ukraine 2016, we've seen them use capabilities to impact critical infrastructure. The other side of the equation is really the operations side, ensuring that our people and our processes are safe, that they're able to create the same output each and every time, reliability, and that they're actually available and in operation, which is kind of aligned to productivity. So when we think about zero trust, it's not just a thou shalt, it's a we have things that our current way forward have not been able to sufficiently address. And we also have unique considerations to keep people safe.
Yeah, and so when you look at these OT environments, they have significant challenges and stark differences between IT. And I just want to take some time to contrast the IT environments versus the OT environments. And the the first thing is that oftentimes the length of service for these legacy devices is 3 to 5 decades instead of 3 to 5 years. You also have a very strong patching cadence that's being dictated in IT, which makes a lot of sense because you're patching typically things that are relatively new within the last 5 years. They're usually using modern operating systems. But patching in OT is just not a viable strategy. In 2022, 35% of all the CVEs or vulnerabilities discovered were what are called forever day vulnerabilities, which means there will never be a patch. Shouldn't surprise you that, for example, Rockwell's Allen Bradley PLC 5s, which went EOL in 2017, they're no longer supported. That's kind of what EOL means. And as a result of that, there won't be any patches for PLC 5 systems, but they're going to be in operation for 10, 20 more years. The fourth thing is that when it comes to IT, it doesn't matter whether you get your email 5 seconds late, but in OT, milliseconds can matter. It can disrupt production, like the triangle that Chuck showed on the previous slide. In OT, you also have highly kind of flat networks. Because they care about performance, because they do not want to impede latency, they set up these any-to-any rules with firewalls, which defeat the whole point, as well as just have these flat networks. And then MFA adoption, I think, is another huge difference between IT and OT. In OT, the adoption is very low, and in IT, it's high. You also have shared devices. You may have an HMI system in a control room for a sewage or water operation. And then you need to have certain vendors access a remote lift station or compressor station in oil and gas. So these are very different needs than going into a data center or going into a data closet. You also have much less standardization in OT. In IT, you've got servers, computers, mobile, phones, tablets. You may have some containers, cloud services. It's very rationalized. In OT, anything that is connected to the network, whether it is a pump, a valve, a temperature indicator, a centrifuge, a electrical substation, there's a highly heterogeneous environment. And when you connect those, it creates a lot more complexity. And then a huge challenge, and I think this is one of the biggest issues in OT, is that you don't have highly certified, dedicated staff to do cybersecurity. In IT, you have people who are CCNA trained or CISSP trained. In OT, you've got people who are just wearing security as a part-time job, as another hat that they have to wear, typically process control engineers. And then the last thing that I think we've highlighted on the last slide is that, safety and availability and reliability are way more important than the CIA triad, which is around protecting data. So Chuck, any other comments you want to talk about, maybe SANS on this chart?
Yeah, so, when we think about OT environments, and the slide is, the title of the slide, talking about how complex the challenges are. The environments that we are talking about are extraordinarily complex as well. You could have, an installation that may have thousands of OT devices whose feedback is necessary for energy management, building automation, HVAC, water flow, health and safety related activities. And in IT, you don't have that degree of interaction between components, which is one of the reasons why zero trust is such a hard topic in the space, is because these devices have to trust each other to a certain degree to be able to do their jobs and primary functions. I think your points on patching, spot on. In OT environments, it's really important to remember that these systems and the software that actually runs these systems is usually built to version for a specific version. And when OEMs and software companies update their software, a lot of times the way that those companies' software interacts with the physical components changes version to version. A great example of that, Windows Service Pack 1 of Windows 7 versus kind of Service Pack 2, they changed the way that they interacted with the network interface card, which is actually why you see a lot of Windows 7 still in OT environments, because the network card itself, has to interact with, say, a programmable logic controller in a certain way. And IT, we're very used to pushing out patches and just being able to do it. Well, in OT, with that degree of specificity, in some cases you have to just rebuild an entire system if you want to patch a single vulnerability. And if you're out in some place like the Pacific, rebuilding a water treatment plant may be a $300 million endeavor or more, which is quite a cost when you think about remediation versus mitigation. I also think it's important to foot stomp, thinking back around some of the other talks that I've done about the SANS 5 critical controls for OT cybersecurity. A defensible network architecture is a core component. And when you talk about that flat network aspect, some of that's on purpose to enable quick, like you said, latency free or latency minimized communications between devices. But there are ways to make that more defensible, which we're going to talk about later on in the webinar.
Yeah, I just add one other pile on to this a little bit on the patching side. Because in OT, so much of the software is vendor specific. It's very different than IT, where it's highly standardized. You have TCP, IP, you have protocols that are rationalized, and there's fewer of them. You have hundreds of protocols in OT because of this vendor specificity issue. That makes it a lot tougher as well.
It really does. And then the people side of the house, I think it's really important for folks to understand that when we're talking about these types of activities and operational technology networks, there are multiple people and multiple organizations within public sector agencies and defense organizations that may have responsibility for each one of these things, who don't have knowledge of the unique requirements for OT environments. You may have a team doing vulnerability management at a centralized level. You may have a team doing endpoint security management, again, centralized. And so it becomes very difficult when you have environments that are as complex as these are, where those centralized folks don't have the context of the system, which makes it even more important to have people locally who understand the systems and can actually do some of these activities specific to the way that their system operates.
You can see we could have a webinar just on that one slide for an hour, by the way, but we're going to move
absolutely.
on. So I think this just really speaks to the fact that because of those differences between IT and OT, there is a fundamental rethinking that has to take place if you're going to protect these cyber physical systems. It has to be fundamental. It's not enough to paper over it or to try to repurpose. And it's kind of the definition of insanity is trying to do the same thing over and over again and expecting different results. This is exactly what we've seen in OT. The IT folks love the standardization. They love the fact that we can do this, but in OT, a lot of these principles that they apply in IT just don't work. So it requires first principles thinking which is why the Zero Trust platform framework is so great for this.
Yeah, and I think it's also really important to just level set with everybody that for years we've had compliance frameworks, we've had best practices, we've had kind of multiple ways forward, right? And it doesn't matter if you're a government person, somebody on the commercial space, if you're, but if you look across and you read the news, environments are still getting compromised. Very mature organizations that have wonderful implementations of cybersecurity programs and frameworks are still getting compromised. I always joke that for cybersecurity, it's like Jurassic Park. Life finds a way, the threat actor finds a way. So we've really got to start thinking about this a little bit differently. Well, not even a little bit, drastically differently, which Zero Trust puts it in a framework that we are presuming the adversary can be successful in compromising our environments, which is such an important concept and such an important change in culture that has to happen when we're talking about OT systems.
Yeah, and so we talked a little bit about Zero Trust, and really this is the bedrock of Zero Trust is essentially assuming breach. It's assuming the adversary is in your network, and then what? And I think some of the NIST 207 concepts, if you haven't read NIST 207, I'm not joking, it's actually interesting, and it will enlighten you and also take some of the fear away from the difficulty in deploying Zero Trust, because all we're really doing is connecting resources with authorized and authenticated users and having a least privileged approach to only giving access and visibility to things that a person or a device needs to have. And that framing is just so powerful, and it applies both to IT and OT. And I want to bring up the fact that because there is no single company, there's no silver bullet that can do all of this. I'd love to be that company, but we're not. And so we have to work together with other members of the community, especially folks like Dragos, who share our own core mission. We both wake up every morning thinking about the exact same customer, trying to solve and protect that exact same customer. So we formed what's called the OT Zero Trust Alliance to try to put together the puzzle pieces so that the customer doesn't have to.
Yeah, and the Alliance has done some really good foundational work that's circulating within the industry. And Tom, I got to give you guys credit for kind of starting down this pathway and helping bring together the community. It'll be really exciting once those products launch, I think, for many people. And it does take a community, right? And this is a space where it doesn't matter if we are complementary, if we're competitors. Like, everybody has a vested interest in ensuring that we can live and survive normally against, even when adversaries who are very dedicated to causing societal panic, as the National Defense annual threat assessment, so the OD9 annual threat assessment calls out, it does take a village. It takes all of us working together to help folks do things the right way, as opposed to just doing things a way and not getting the outcomes we want to achieve.
One could even say it is the way.
You could. When we talk about Zero Trust in context of the Department of Defense, you may be familiar with this image of the Zero Trust pillars. And I think it's interesting when we read the documents that are out there that everything centers around data. And that conversation and that data centricity is correct when you put it into context of the traditional information technology CIA triad: confidentiality, availability, and integrity. And when we think about data within IT environments, the data that we're typically most concerned with protecting, things like mission relevant information, intellectual property documents, plans, operation orders in the Defense Department, things that if they are compromised, have an impact to a mission, have an impact to people, or to trust within an organization. This presents, though, a challenge for operational technology space because we're not focused on data. If we go back to the OT triad of safety, reliability, and productivity, we're more focused on delivering the same output concurrently without having impact to life safety or process safety. And so those communities, this is where we're really kind of at odds with the information technology space, in that we have a very different focus and very different perspective that we're coming to this conversation with. That doesn't mean that we can't work together. That doesn't mean that the principles that have been developed within the IT space can't be applied to the OT world. It just means that when we're thinking about how we're prioritizing the many, many, many different requirements, we have to look at the requirement first from is it safe to implement? Is the implementation of this going to prevent an operator from accessing a terminal to issue a stop command or to change a setting within a system? Is this control going to result in a network connected safety system being isolated from the rest of the network by a isolation capability that doesn't know the context of it, and now we can't do an emergency shutdown automatically because our safety system can no longer communicate to all the other different components? We have very different considerations. Our end goals are the same: to be able to protect our people and ensure the mission succeeds. But the implementation approach and the considerations that have to happen, like Tom mentioned, latency requirements, must be considered any time that we are talking about implementing an operational technology controls set. So we're used to, and Tom, you said this really nicely earlier, we're used to being able to apply kind of blanket policies across our network connected enterprise. And that works really well with information technology systems, where there is a standard way that things communicate. There's a core set of protocols that you typically see. You kind of know what to expect, right? And again, can controls apply? Can zero trust controls apply to OT? Absolutely. But there is a element of uniqueness to every environment. And so when I like to think about zero trust, what I like to look at these controls is in a lens of what layer of my architecture can I realistically apply these controls? What type of environment? Let's say that we're in an energy distribution space, so we have substations, compared to just a building automation space. Building automation, building management is an incredibly complex topic. But compared to a building management system where maybe we're not as concerned with latency, we could skip a cycle of control for an HVAC motor compared to, if we miss the ability to trigger a relay to open a circuit, that may result in somebody dying out in the field. So as we think about the realities of zero trust in this space, you've got to involve those subject matter experts from the engineering side of the house, from the OT networking, OT cyber community, and even you've got to involve vendors because some of their systems may have unique considerations across the board. Tom, any other comments on this one?
Yeah, I would add one other comment to that. Let's just take the building management example you just gave. If you think about in IT, you typically don't have a lot of outside vendors who necessarily need to get access to a rack. Whereas in OT, on that building management use case, you may have an HVAC technician who absolutely needs to get a remote access to one of those components and may need to perform remote troubleshooting. And so that you may have dozens and dozens of different vendors who need to do that remote access into a ecosystem, which again looks very different than IT.
Absolutely. I was just thinking about around the vendor kind of comments that we've made so far. It is very difficult sometimes for the Defense Department to interact with vendors safely. There's a lot of fear around reaching out to a vendor, asking for information that I see like on a day-to-day basis. And that's something that we should probably as a community flag as an item for later just for discussion, because anytime we talk about these systems, you really need to have the folks from the vendor community in the room so that they can provide their input. If we're not doing that, we're putting ourselves at risk as we kind of implement this stuff. And so that may require folks within the department to actually, kind of think about creative ways to establish relationships. Some organizations are using CRADAs, cooperative research and development agreements, to kind of establish these knowledge sharing kind of capabilities. There's a lot of ways that you can skin the proverbial cat on that, but I think it is something important, not just in implementation, but also thinking about incident response and system recovery, right? You've got to have those things in place before you have to deal with a real world issue.
Yeah, one thing I would add also, Chuck, to that is around the blistering pace of innovation that is taking place in the world today. And whether you're talking about how AI is amplifying the threat vectors that have been successful today to a whole new level of order of magnitude. So because of that blistering pace of innovation, that's yet one more reason why you want to work cooperatively with some of the thought leaders, vendors, et cetera, laboratories who are on this cutting edge and who are trying to stay one step ahead of the adversary.
Yeah, absolutely.
So with this, let's talk about a case study in which this is actually the very first time on the planet that zero trust was implemented in an OT environment. And that is not my opinion. That is the opinion of the two-star equivalent who heads the CIO's office for the DoD for zero trust. And that's Randy Resnick. That was his assessment of this project that he also and his organization funded through taxpayer dollars, of course. But the thing that's salient about this is there is this mandate that the DoD wants to achieve zero trust by 2027. And Randy's office laid down the gauntlet on this kind of a mandate. It's extremely aggressive. There's a lot of moving parts. And this is a new concept that requires a wholesale change in the way we do digital transformation in the DoD. So this pilot was the first of its kind to demonstrate that zero trust was actually possible in an OT environment. And what we did is we worked with two other vendors that BlastWave was the lead. We worked with two other vendors, Nozomi and Darktrace. And we were awarded this pilot that allowed us to protect this water treatment facility and sewage treatment facility that included multiple buildings in multiple locations. And one of the shocking things is that we were able to start and complete this project in 60 days. When Randy was kind of evaluating whether he wanted to do this project, I still remember the meeting because I was asking him, what do you think would be a reasonable time for us to complete this project. This was like November, early November. And Randy said, he stopped and he thought, well, I think it would be unreasonable for us to be able to have this done by January 1st. And of course, I about fell out of my chair because I was expecting something like the fiscal year, September, maybe the summer, worst case, maybe April or March. And he said, well, so maybe January 15th would be a good date. So he basically said, can you do this in 60 days with 2 other vendors doing something that's never been done before? And we did it. We completed the project on January 8th. And one of the interesting things is that we actually installed the BlastWave solution in 4 hours. And some of the other components require some training. They have some sophisticated AI algorithms that do take some weeks to spin up and figure out what normal looks like. And so we got this whole thing done, and the CIO's office at the meeting in Germany said this was nothing short of a miracle, that this was amazing what we were able to do. We protected 91 devices in 89 microsegments. And we also included passwordless multi-factor authentication, which is something that I think is a wave of the future, because passwords are something that I think are very easy to get socially engineered out of you. And this is something that we feel very strongly about. So it was a very successful kind of case study of what's possible.
Yeah, so just really quick, I want to go back to one of the previous slides, because somebody asked a really good question in the chat around, what are we trying to say with this big red X mark over zero trust? I think it was Peter, and thank you, Peter, for bringing this up. We're not saying that you can't do zero trust within OT environments. What this slide is intended to show is that the approach from being data centric is not the same approach and perspective that we have in OT. So we're going to talk a little bit about how different controls apply to different zero trust controls apply to OT networks. But again, just foot stomping. In OT, we care about safety. So if we were to actually rewrite the pillar, which there is no actual standard for zero trust within OT. So we have an opportunity to work as a community to kind of build this out. But if we were to take that diagram where data is in the center for OT, we'd want to swap that with safety because that's our number one focus. And then we would look at the different tiers and different layers. So we'll talk a little bit more about that, but I just really wanted to jump on that question because I thought it was a really good one, and I'll try my best to figure out a way to kind of re-engineer that slide to make that a little bit clearer from an understanding perspective.
So let's talk a little bit about the OT Zero Trust Alliance. There were 2 questions in the chat about this. And, it really comes down to there are 9 different folks who are part of the OT Zero Trust Alliance. One question was, who are they? Here they are. Another question was around, can you be a system integrator? Do you need to be a vendor? Well, we have 2 different system integrators already part of the Alliance, Booz Allen Hamilton and BCG. And then the third question was really around, what does it take to become a member? We've got a invitation process. You can go to OTZTA.org if you want to apply. You can also just send me an email directly, tom@blastwave.com. So hopefully I answered 3 questions in the chat that I saw. A little bit about this. This just really helps show you how when you map this, if you step back and squint your eyes, we tried to come up with a way in which we could have complete coverage over the NIST framework. And this just shows you kind of how all these pieces fit together. So Chuck, do you want to move on to the next slide?
So actually, I would like to, well, apparently my mouse wanted to advance. I just want to highlight the addition of governance to the conversation. For organizations that have very complex structures, the governance side of the house is potentially one of the most important pillars of this entire conversation. Because if you have multiple decision makers who are all responsible for different things, different funding streams that are all responsible for different aspects of this. You've really got to, have a person or a group that can help facilitate those interactions. And so that's something that, as I do more and more work within the DoD in particular, so incredibly important to get right, and to acknowledge that there are going to be some challenges around roles, responsibilities, decision-making authorities, and governance in this space.
Okay, Chuck, you goaded me into making another comment about this. So, I mean, there's another kind of principle. If again, thinking about first principles relative to cybersecurity, it's always about the weakest link. These adversaries are lazy in a way. They want to find the easiest possible way to compromise your network, compromise your system, and extract value, achieve their mission. And the weak link is oftentimes in these kind of cracks, the interfaces where things fit together. And that's why that governance piece is so important. And it's why we find it extremely important to work with these system integrators, like BCG and Booz Allen Hamilton and others, because they're doing cyber assessments. They're typically looking at where all these cracks are and then making sure that we work together collectively to try to fill them, so that it just makes it much, much harder for the weakest link to be that weak.
Absolutely.
All right. So I'll just stop there. Now, Chuck, I'll talk about this a little bit, then you can dive in. This was the first, with the knowledge that we've gathered from our trial and the pilot, we worked with the OT Zero Trust Alliance community collectively, and had a lot of collective wisdom, hundreds of years of collective wisdom in terms of how to transpose those IT zero trust requirements to OT. And this is a different fan chart. There are 91 IT zero trust activities at target level. There's another 61 at advanced level. So 152 activities in IT. In OT, you'll notice you don't really see a lot of the data, as many of the data issues here as you did in IT. So it's about 50 instead of 91 to target level. And this is a work in process. This is the first draft of its kind. And there are a lot of, I'll say, very important people who are revising this, thinking about it, adding to it. So this is a work in process. Daryl Hagley, I'll just have a call out to him. He's played an instrumental role in helping bring this together. And so really appreciate the work that Daryl is doing and his team. So any comments on this specifically? Maybe there's some things we could dive into, Chuck, here on this.
Yeah, we're gonna talk a little bit about some of these broad categories of controls in just a second, and I want to be cognizant and leave some time for additional questions and answers towards the end of the session. I want to just foot stomp that when we say, and when we have the logos next to certain pieces of the pie, right? That doesn't necessarily mean that individual control applies to every single component within an environment. Great example, a sensor that's a pressure sensor is probably not going to have, well, nowadays, depending on how it's built, if it's industrial Internet of Things, it could, but traditionally, a pressure sensor is not going to have a login interface for a password. It's going to send a digital signal to a controller, which would have a login. So what folks are struggling with this whole IT/OT convergence discussion, and zero trust is right in the middle of that, right? Is that now we're starting to see those lower level components talking over Ethernet as opposed to these serial or bus type communications. We've just got to be aware that now that these lower level devices are starting to become a little bit more prevalent, and we're starting to get creative over the fabric transport that we connect, that it may look like we can apply a control because it's on the network. However, we may not be able to from a technology perspective or from a life safety perspective.
Yeah. And again, we could have a webinar, and maybe we should have another webinar on just this chart and kind of really double click on these requirements, because this is where the rubber actually hits the road. And it could be fairly overwhelming.
Yeah, and I also would say that when we're thinking about this, when you think about, operational processes and kind of the risk calculus in deploying solutions, a lot of what we're talking about is in production in multiple different types of industries today. So this is not a conceptual, we think that we can do these types of things. This is a, hey, we have done these types of things. They've been done safely. And again, having that relationship where you can have these conversations with the folks that are, kind of deploying and building the technologies, bringing in the engineers, so important in being able to do this safely, and being able to do this in a way that enhances operational capability and doesn't take away from it, which a lot of times when people in the engineering community think of cyber, they think about the no, I can't, no, thou shalt not, as opposed to what we should be doing from a cybersecurity perspective, which is hey, let's figure out how to do that safely.
Yeah.
And a lot of those conversations can happen as you're talking about these different controls, right?
Yeah, let's try to get through this next series of slides in 7 minutes so we can open up some time for questions. So let's talk about what is BlastWave, because a lot of you folks don't know who BlastWave is. We were a startup, we were founded in 2017, and we deliver zero trust protection by delivering 3 things in a single product. We essentially cloak your network, which means that your devices are not discoverable unless people have been PKI authenticated, and unless they have the right authorization as well, then they can't see anything and they can't connect to anything. So that network cloaking is really important. Plus, the added benefit is that allows you to segment each one of those enclaves, if you will, of your network, so that they're in logical groupings, typically in things that make sense from a process control standpoint. You have to work with the process control engineer who understands what are these logical groupings as opposed to being dictated from on high. The last piece that we allow because of these capabilities is we can then allow that direct, secure remote access to remotely manage, anything on that network. And there's all kinds of great features about allowing someone to only work on this between 8 a.m. and 5 p.m. Monday through Friday, and it automatically can revoke the privileges and access for these folks, which is another legacy that leads to a lot of breaches. So that makes it very clean in terms of zero trust, meaning we only give you access and visibility to the things you absolutely need to get access and visibility to. And once that's the case, those are revoked. So next slide, please. And this just talks about this parallelism. We have segmentation that impedes lateral movement. Lateral movement, these are these entire classes of risk that BlastWave was designed to eliminate. It's not going after things in a kind of a game of whack-a-mole. It's trying to eliminate entire classes of risk around lateral movement. If you're looking at segmentation, if you're looking at discovery, which is being, again, weaponized through AI, automated bots going everywhere, looking for CVEs, looking for things that they can exploit. And the cloaking then addresses discovery, and then initial access. We also have password resistant or phishing resistant MFA that doesn't involve usernames and passwords. Again, I spent a decade at Apple, and this was patterned after Apple Pay. So you essentially authenticate in a very fast 3 seconds to 5 seconds without having to remember anything, which is great, but better, it means that no one can trick you out of disclosing that information.
So just really quick as we move on, the initial access, secure remote access, is a great example where we have a place where some of the more advanced zero trust controls can be applied. So think about the ability of using user behavior analytics, user location, things of that nature as part of the authentication process for remote access coming from outside the environment to inside. Whereas, if you're inside the network and say it's a human machine interface that's a touchscreen, you're not going to want the chance that you're going to be denied access when you need to push a stop button on an HMI. So secure remote access, I feel, is like a great example where we've got a higher level control versus a lower level space that we can show what that looks like as you go further down.
Yeah, and in my way of thinking, by the way, I think of the idea of remote access is irrelevant. It's just access. You want to have zero trust access, whether you're on the inside of the network or you're on the outside of the network, and that's an important reframing. So,
absolutely. So when we think about kind of those categories of control aligned to the NIST CSF, we're going to talk really quick about identify, detect, and then response, because those are three areas that are foundational and enablers to the greater zero trust framework. When we talk about identify, most people are used to framing this in the construct of assets, so having an asset inventory. Unfortunately, in many environments, because they don't have automated tools and capabilities to create and continuously update asset inventories, we still have folks that are doing this on spreadsheets today, which is really hard because you may have components get swapped out on a daily basis because a motor burns out, or it's just time to upgrade like one specific piece, and it's hard to keep up with that on a spreadsheet. When we think about zero trust, we expand that identify to both people and accounts. So both human personas and non-human machine personas. And that's really important and a key thing to understand, because when you think about some of the more advanced zero trust capabilities, they include all those types of considerations. And then as we're thinking about, hey, BlastWave layering on top of the network, kind of cloaking those communications, it becomes very important to understand the network flows, how applications actually work and interconnect with each other, and how services on systems are being utilized and interacted with across the network. In general, I come across two different types of environments. One is, hey, we have a pretty good grasp on our systems, on our people, on our assets, and we already have mapped out, these types of things, which is awesome. Makes things like BlastWave incredibly, it's that much easier to implement on top of how easy it already is. And then you have environments that, they don't have visibility, so they don't have those kind of characteristics. And that's where, a solution like Dragos platform really helps folks get some of that foundational knowledge that, again, will kind of give an extra degree of safety, a degree of reassurance, and just better visibility overall as you're trying to implement some of these capabilities. Tom, any comments on the identify and the importance of that piece?
It's just critical. You need to identify what's on the asset on the network, and then once you've identified it through APIs, we can actually figure out a rubric for how to then provide rudimentary protection mechanisms, protecting them with, again, in our case, Blast Shield. So you need both of those things to fit together, and they amplify each other's power.
Definitely. Then we have the detect side of the house. And when we think about detection, usually the two things that people focus in on are threats and then vulnerabilities. I have heard the question, well, if I've cloaked my network, why do I really need to worry about the threat perspective? Because we've eliminated, external access. And Tom, you brought up a really good point earlier. It's not just what's outside, it's also what's inside and already here. And unfortunately, adversaries are just as good at compromising people as they are at compromising machines and equipment. And there's over 24 threat adversary groups that are focused on compromising operational technology environments that Dragos is tracking today, which really means that we have to be able to see what's traversing this space, because a lot of the systems we're talking about can't support things like endpoint security and solutions of that nature. And we need to be able to understand the specific protocols and adversary TTPs that are associated with OT environments on the network at all times. And there's all the other kind of benefits that go into having that continuous threat detection, which include having a continuous updated asset inventory, having a continuous view of what vulnerabilities are within the environment and how they apply to that environment. And the detection of vulnerabilities is also really important for OT. We may not be able to patch them, but we absolutely have to understand where vulnerabilities exist, how accessible they are to folks internal to or external to the network, and how those vulnerabilities, if they were exploited, could impact the process. And again, understanding how things talk to each other, how things communicate, and their dependencies, which is what you learn when you have visibility, are key enablers to all aspects of what I just talked about. Tom?
Yeah, Chuck, I was just going to bring up a term that I've used before called asymmetric visibility. And this is where you want to have perfect visibility as the asset owner or the cybersecurity SOC or whatever it is. And you want to have zero visibility for the adversary. Obviously, that can be very challenging to deliver. But around visibility, if the adversary can't see anything, whether they're an inside threat and outside threat, if they can't see, can't connect, or the devices are non-responsive to pings, then even those vulnerabilities that are never going to be patched that I talked about before, they're not going to be exploitable because you haven't authenticated and been authorized to see them first. And so it's a very powerful security blanket, if you will, to deal with these vulnerabilities and threats. Again, this is where this power of the combination of a continuous monitoring visibility tool like Dragos and a protection tool like BlastWave is just such a great combination. So 1 + 1 = 16.
Definitely. So when I first became aware of technologies like BlastWave, I immediately thought about the concerns that I've heard from the process control community around the dangers of automation, the dangers of just kind of isolating components, like the example of a safety system that I used earlier. What we are starting to see is folks open up to the idea and the concept that we can automate in different ways that are safe. And Tom, if you want to talk through, kind of the scenario that you have in the diagram here, I think it's really good to, kind of understand what those could look like, as well as the importance of working with the engineer community to map out these types of activities.
Yeah, and it goes to some of the concepts we talked about before by working with the subject matter experts, process control engineers who really understand what these requirements are, what needs to talk to what, and what is, what are the latency requirements as well. And I think this diagram just shows you that you have a malicious insider. And if you can do layer 2 isolation where maybe they can get access to the bottom PLC, and if you have layer 2 isolation, then that malicious insider won't be able to see any of the other things on the exact same local area network, which is, again, a very powerful way to provide protection and eliminate an entire class of risk. The other thing that's important about this diagram is the concept of DMZ. And I think this is something that the community has become very aware of, and the need to isolate the IT network from the OT network as a kind of fire break, if you will, so that things like the Colonial Pipeline, which they were worried about once the IT system was breached, that those issues can be mitigated. The other thing that's, I think, important about this diagram is it's transport agnostic. You could do this exact same thing, this protection and visibility combination, over SATCOM. You could do it, obviously, over industrial Ethernet. You can do it over any transport whatsoever. And the remote users can be anywhere. The devices that connect to this can be anywhere. And then BlastShield can enforce those policies in such a way that as an issue gets identified and flagged through a visibility tool like Dragos, then you could actually do that revocation in real time. One of the things we do in a demo for our customers or potential customers is show just how real time this mechanism can be.
Yeah, it's amazing the art of the possible when you actually understand the process, when you work with the engineer communities. You can do some really amazing things to put roadblocks in front of adversaries and frustrate them, which also helps from a detection standpoint, because the harder they have to work, the more visible they become. And so you get kind of this continuous loop of improving visibility, protecting systems, causing adversaries to expend time, energy, effort, and capabilities that has many, many benefits to members of the cybersecurity and operational community. And I just close the slide before we go to Q&A, really with foot stomping that you can implement aspects of zero trust within OT. You can implement these types of technologies, these techniques, these procedures, not just from a technical perspective alone, but you can actually do them safely. Mm-hmm. But you've got to do it in the context of the specific environment you are deploying to. And you must have people that really understand this, because, just think about, from a maintenance troubleshooting perspective, you are adding an additional thing for those engineers to acknowledge and think about when they troubleshoot, when they have to go through kind of their step action drill. That's why working with everybody within the community is so incredibly important when you're doing these types of things. Yeah. Tom, any other thoughts before we go to questions?
Two comments, one of which deals with questions. The first is the Zero Trust Office at CIO has a North Star that they try to navigate towards, which is to stop, contain, thwart, frustrate the adversary from gaining access, visibility, or lateral movement. And that North Star, I think, is a really important principle to think about as you stress test potential solutions. Second comment, I just want to thank Cam Cullen for doing the heavy lifting of answering all the questions in real time, so Chuck and I don't have to.
Thanks, Cam. All right. I think with that, we'll turn it over to Q&A. We're happy to answer any questions that folks have.
Well, we have 23 answered questions in the chat.
Yeah, I was going to suggest if you have any of the answered questions you want to elucidate on, feel free.
Yeah,
let me stop sharing.
I would say, so there's one question that caught my attention, which is this issue around the fact that it's actually fairly easy, some cases, to get physical, to compromise a network physically, like an electrical substation or electrical lines or something like that. And how do we think about this tension between physical security and cybersecurity? And what I would say is you need to have both. Again, the fundamental principle is the adversary is trying to find this easiest, simplest, cheapest path to compromise your network and achieve their mission or their objective.
Yeah, somebody brought up in the chat, distributed energy resources. Actually, it was Peter. Distributed energy resources, DERs, like solar, microgrids, things of that nature. Absolutely, yes. When you think about those systems and you think about the role that they play in resiliency, being able to support, protect, monitor those environments is just as important as being able to do the same thing in kind of the more production as opposed to the resiliency side. And in many cases, DERs are production; they are providing prime power, right? And pushing things back to the grid even. So, many of those systems are networked. A windmill is a great example of a place where you don't traditionally think about putting a sensor. However, they are potential points of compromise. There are network connections in even environments like that.
Yeah,
it is absolutely important to think about that.
So there's one thing I'm going to address, and then two, that I want Chuck to talk to. One is, yes, it's sad that we can't be everywhere at once. I apologize that we can't make it to Black Hat. We've got a lot of other things that we're committed to. And then the other question is, there was a series of questions around new technologies and where is cybersecurity going and what are we worried about? And Chuck, I'm going to turn this to you. What are you concerned about in terms of some of these new quantum AI kind of systems? Someone suggesting a CAS chip. Maybe there's other kinds of things that can be done to mitigate these. Maybe talk about some of the technology trends that you're seeing.
Yeah, so somebody from the Air Force Research Lab, one of their lead cybersecurity researchers, did a webinar like 2-3 years back. And a statement he made has stuck to me. He said that no matter what protective measure we take, adversaries will figure out a way to compromise it. Which is why the ability to know that an adversary has compromised something, that they have made it through the network, becomes so important. So when we look at our typical and traditional investment, we typically spend about 90% on protection and 10% on every other one of those NIST cybersecurity framework kind of pillars, right? We need to change that paradigm. We need to start investing more in detection as we get more and more capable adversaries, as they do start to develop those capabilities that may leverage next generation computing capabilities like quantum and artificial intelligence. We need to actually invest just as much in detection as we do in protection, and really link those, like we're talking about here with BlastWave and Dragos, so that they can inform each other and build a better ecosystem. Regarding the question around trends and developments in OT cybersecurity, I think the next big thing that we're going to see is OEMs including more baseline cybersecurity capabilities within their products. A great way, in a great example of that is Rockwell, in one of their latest Allen Bradley PLC releases, now has included the ability for that programmable logic controller to send syslog messages for things like logins, logoffs, system events, things of that nature. That's a game changer. Before this, we've never had the ability to actually see that data other than monitoring the network. So now we have another source of data that we have to take into account. And so I think that, when we're thinking about capabilities, OEMs are going to give us capabilities. We have to make sure that, one, we're mature enough to use them, and two, that we have the ecosystem to be able to bring that data in and actually operationalize it.
Yeah, and Chuck, I just want to say I love you, because you're the yin to my yang, and we're looking at things from two different sides, trying to solve what I think is extremely important service to the country and to the world, and to these operators, where this is where the real shit gets done. This is where, the physical world is something that a lot of people kind of are overlooking these days, because there's so many exciting things going on in the digital world. But ultimately, we have to eat. We have to generate power. We have to move products. There's logistics. And this physical world that we live in is being increasingly connected. And we've got to work together to find ways to protect that from all these threats, wherever they may be, inside or outside, China, North Korea, Palo Alto, wherever.
Yeah, no, I mean, that's the entire reason that I got into the space, was because I realized that in order to have email and a data center and cloud to protect, you have to have power and water. Without these foundational building blocks, which are now becoming increasingly more connected, and they're being connected for the right reasons, driving efficiencies, lowering cost to people. Actually, the entire reason the industrial automation community exists is to make processes safer from a control perspective. So all of those things are driving these connections. And it's such a privilege to be here working with folks like Tom and the team from BlastWave and every other member of the community to keep people safe. And really appreciate everybody's time. Tom, anything else? Cam, Rachel, anything else to close?
I think we've run over, but I just want to thank everybody for your attention and for your time in hearing some of this important information that we were trying to share. And if you have any questions whatsoever, send me or Cam an email, or Chuck, Kelly. So just send email, reach out to us. We're all trying to solve the same problem.